Good afternoon, everyone. I hope all of you are doing well. On behalf of Mason Labs, I would like to extend a very warm welcome to everyone joining us today for this webinar on rapid electric motor design and multiphysics validation with Simcenter FluxMotor. I'm Sujit Pillai, Technical Manager at Mason Labs, and I'll be your host for today's session. Thank you all for taking the time to join us. We have participants from various organizations and industries, and we are delighted to have you with us. As you all know, the electric motor development has become increasingly challenging, and the engineers today need to achieve higher efficiency, better performance, lower NVH issues, and improve thermal characteristics and shorter development cycles, all while meeting demanding market expectations. So this has become a more challenging scenario, and this makes having the right design and simulation tools more important than ever. And in today's webinar, we will explore how SimCenter FluxMotor helps to address these challenges by enabling rapid motor design, automated multiphysics validation, and seamless integration with detailed simulation workflow. So we'll also have a live demonstration. You will see how engineers can quickly create motor concepts, evaluate their performance, and significantly reduce design iterations. Before we begin, I have a couple of quick housekeeping notes, which are, the session will last for approximately 45 minutes to 1 hour. We encourage you to post your questions in QA window throughout the session. We'll be happy to address them during the QA session at the end. Now, without further delay, it is my pleasure to introduce our speaker, Mohammad Simak, who has extensive experience in electric machine design and simulation. Over to you, Simak.
Thank you for the introduction, Sujit. Welcome everyone to this webinar. I will just share my screen. So welcome everyone to this webinar on rapid electric motor design and multiphysics validation using Simcenter FluxMotor. So as we know, we are living in one of the most significant technological transitions in modern engineering. So across industries, right, whether you look at it from electric vehicles or aerospace or industrial automation, renewable energy, home appliances, and robotics, electrification is no longer a future trend. It is the present reality, right? And at the heart of this transformation lies one critical component, the electric motor. So today, engineers are expected to design motors that are not only more efficient, but also lighter, quieter, more compact, and more cost effective, all while reducing development time and accelerating innovation. And the traditional design approaches, right, what industries followed, so they often require multiple iterations, extensive prototyping, and significant engineering effort before arriving at an optimal design. So this is where modern simulation driven design is changing the game. Okay, and we are focusing primarily on a software called as FluxMotor. It is a dedicated electric motor design platform that will enable engineers to rapidly create, evaluate, optimize, and compare different motor concepts long before we would need to build a physical prototype. Okay, so whether end users are exploring a new topology or evaluating performance or validating design feasibility, FluxMotor will help us engineers make informed decisions much earlier in the development cycle. Okay, saving both time and cost, which are critical in today's industry. Okay, so now I will just take you through the agenda for today's session. So we will first look at our complete global workflow for e-motor design, what we offer here at like from Siemens, and then a brief introduction to SimCenter, the different software portfolios, and then we'll be looking at what FluxMotor is and why we should be using it, what the different strengths and capabilities of the software are. And we'll be looking into a live demo of the tool where I'll walk you through all the different, capabilities and features, the GUI and all of that. And finally, we'll be looking at a case study and a testimonial as well before we proceed to the Q&A session. Okay. So as Sujit mentioned earlier, please feel free to drop your questions in the chat. We will discuss them towards the end. Okay. So this is the global workflow for e-motor design, what we offer here from Siemens. Okay. So initially, then this is what we'll be looking at in detail in today's session is the concept design, wherein we can finalize the best topologies rapidly for our applications. This is what FluxMotor enables us to do. Okay. And then we can proceed to the detailed design, either be it efficiency, cooling, noise, or the electromagnetics using our dedicated solver, Flux, OptiStruct, and AccuSolve, all within a single GUI called as SimLab. Okay. And then for system integration, if you want to integrate your motor with the different components of your machine, right? And you want to see how it behaves, whether it is meeting the capacity, okay, or if something's going wrong. To do all of that, you need to software to integrate different domains along with your motor, right? So that we can do it in a software called as Simcenter AMSIM. And so basically what we do is we would take the motor we designed here in Flux Motor and we just export it there. And then, do the entire system design and verify our results there. So much before you get to the prototype stage, you'll have a pretty good idea of how your systems are going to behave. So hence it will save you a lot of time and effort and cost. So from concept to system, we can accelerate innovation and deliver outstanding e-motor performance. Okay, this is just a brief introduction to the SimCenter portfolio of solutions, simulation and test solutions that enable us to model the different complexity involved in the different physics, enabling us to get detailed insights and explore new possibilities so that we can, take decisions with much more confidence and go faster. That is the main aim of simulation, right? To get more efficient, to save as much time as possible and stay integrated across domains. So solutions are available right from structural, fluids, thermal, electromagnetics, acoustics, chemistry, electronics, and more. And they have a seamless connection. We have a seamless connection between the different software that enable us to that enable different design teams and us to quickly do interdisciplinary, interdomain simulations and analysis, quickly transfer models, quickly transfer data. So that is a pretty seamless process here. Okay. So Flux Motor, it is, as I mentioned, it's dedicated to addressing the global design of electric motors. Okay. So it is a dedicated standalone and multi-physics platform for e-motor concept design. So what happens here is you're not starting from scratch. You're starting from pre-built topologies, pre-built templates of a wide range of motors that are available in the software. All we need to do is we just need to, pick and choose what we want to know. And the software works in a analytical input manner, as in you're just entering numbers here. You're not really going the traditional design way of creating the geometry and then all of that traditional process that you need to do. Instead, you're just entering numbers. So even a person who's a beginner, let alone an expert, can pretty quickly design their motors here. So you're just entering the numbers for the different components of the motor, say, and for components like the magnet and the slots, you can pick and choose. Since we cannot directly define it from a number, we need to visualize it, right? And since we are not manually drawing any CAD here, what you can do is we have set a huge set of library of components. Of course, we can bring in our own custom parts as well, and you can just pick and choose and quickly parameterize and go with your design. So it enables engineers to accelerate the design of machines, and it's a pretty intuitive and modern GUI and one of the most simplest user interface of any software in the market. It is that straightforward, as I'll show it to you. Okay, so even if you're a beginner or just generalist looking to quickly get a side project done, or an expert, right? So it'll allow us to the software will allow us to efficiently create, analyze, report, and optimize electric motors. So hence, it'll help us to power innovation with a dedicated platform for e-motor design excellence. And yeah, so why should we use FluxMotor? Why use FluxMotor, right? So fast evaluation of techno-economic performance. Okay, and another thing, first is what we do. As I mentioned, entering the or creating the model is pretty straightforward. All you need are numbers, and you just need to pick and choose the type of magnet and slot that you need, right? For defining the winding, the software is quite helpful. There are different modes which the users can use if they want to manually configure every part of the motor. You can do that, or you want the software to run the winding design for you, right? We can do that as well. Hence, that is also taken care of very smoothly. And then what we can proceed from there is we can go to the tests. And unlike a traditional FEA, like FEA based software, wherein to set up each test there is a lot of pre-processing involved, and even after you've solved, just to plot the graphs, there is quite a few steps that you need to do. Herein that is not the case. We have automated tests, okay, across domains, right? So you can do electromagnetics, thermal, and NVH analysis and tests here. So you just need to enter the inputs again, just numbers here, and just run. We get a nice small solve button, which looks like the YouTube play button, and then the software will quickly solve, and it'll give us a wide range of outputs, not just one or two things, a huge a range of outputs will be available. So we can, and all of this is just within a matter of minutes, right? So, and we'll be able to quickly go through, make informed decisions, and you know and we have a strong export option as well, right? Within minutes it generates a how do I put it, yeah, a PDF report, okay, of whatever you want from the motor. Either it can be every single thing that the software provides, or your specific requirements, what you need to provide, okay, to either your customer, or or your whoever you're working with in the industry. So for that we can choose it and we can do it, and that too will get done within a matter of minutes, right? And yeah, as far as assigning the materials is concerned, we have an in-depth library of materials. We just need to just pick and choose and assign the materials. Okay. So as I was mentioning, so all of this will enable us to conduct fast evaluation of the techno-economic performance, right? Both on the technical side and on the economic side. We need to be sure, right, whether our motor is compact enough, how much the materials is going to cost, whether it's going to be easy to manufacture a certain type of winding. So cost plays a huge role. It's not just meeting the technical requirements, right? The motor needs to fit in whatever as whatever machine you're placing it inside, right? It shouldn't cross a certain weight limit, right? It shouldn't make too much noise or cause too much vibrations. It shouldn't get heated up too much. There are a lot of things that you need to look into. So all of that we can do it very quickly here, right? So so fast evaluation of techno-economic performance, and rapid concept exploration, and the product feasibility check. You check whether your product is going to be fine or not pretty quickly. And yeah, it'll enable us users to make documented decisions quickly, and it is accessible to a broad range of users, as I was mentioning. Let's go to the next slide. So yeah, the strengths. It's an intuitive interface and workflow, which is very easy to use. So the workflow basically just involves three steps. One is the design, where just by entering and varying numbers, you set up your entire machine and you can easily visualize it. So the user need not have the traditional simulation knowledge. The traditional simulation knowledge in the sense that what we need to setting up the geometry, and then meshing the software, meshing the model, assigning the materials, and then setting up the test. All of that effort need not be put here. So even a person who's completely new to simulation can pretty easily get started. It almost works as a calculator of sorts, right? And it has customizable templates which are parameterized. So again, it's just basically just entering numbers, and it has a user oriented winding tool, which basically means again If you want the software to do all the design of the winding for you, you can just let it do it. Or if you want to model certain parts of the winding and let the software help you with the rest, we can do that as well. Or you want to do it completely, again, that is completely on the user. Okay. And as I was mentioning, predefined tests are there. So to quickly get the results and that we need, and automated reporting also within seconds, it will generate a detailed PDF report. And it is a pretty straightforward workflow. You just design it, you test it, and then you export it. And it is not just that you can export the data, but the software is pretty open. You can do a lot of co-simulation or exporting to different software, such as I mentioned earlier, you can do system integration, right, within us in our system integration software, Amazon. Or if you have a motor controller team, okay, you want to design the motor control unit or the traction inverter for your motor on your own, you can send this motor and they can do the motor controller design in a dedicated tool for that called as PSIM. It is focused on primarily on power electronics and motor drives. So there is a very seamless workflow between different software here for very easy to export. And a new machine project can basically be created within minutes. So it's designed for simplicity, built for performance, and so we can effortlessly create, analyze, and optimize electric motors. So what you see in the screen is basically just a GUI of how the design window looks. You see the 3D model here of the motor, and then you see the different components that needs to be designed to complete the motor. And this is just like previous sorts of the how the report would look. Okay. And it is, yeah. So I mentioned to you how we input it, right? But now I'll tell you how the software solves it and how it ensures we get how it ensures we get the most accurate results, right? It uses a mixture of finite element analysis along with some analytical calculation and inbuilt optimization techniques. It uses a combination of all three to ensure that we get the most accurate results. In fact, we can even view the mesh in the software, but it's all taken care in the background. We really needn't think about it at all, but that's just to assure you that the results will be accurate. We have very nice combination of finite element analysis, analytical, and optimization techniques. Okay. And we can predict machine performance at several working points or over a complete duty cycle to meet multi-physics requirements. So even at the early design stage. Okay. So what you see is here is the efficiency of the motor in the torque speed area. So it is fast, accurate, reliable, and it'll enable confident decisions from the earliest design stage. So we can optimize our machines for performance, efficiency, and innovation. Okay. And then, yeah, more strengths or more capabilities of the software. So effective parts management, as I was mentioning, be it for the slots or the magnets, a very wide library of components is available. We just need to pick and choose and, parameterize and use it basically. And we can bring in our own custom parts as well. So from the Flux 2D capability of SimLab, we can just sketch our custom CAD and we can easily bring it here and use it. So smart libraries and parameterized topologies, so we can manage, customize, and create machine parts with speed and flexibility. Okay. And so that we since as I was mentioning, right, we can design these within a matter of minutes, right, if we have all the right data. So there is a lot that you can do. So what that calls for is a feature to efficiently manage, right, all the different projects or models that you're going to do. So we have the motor catalog, which helps us to do just that. We can very neatly organize all the different motors that we are building, depending on their type, application, and more. And we can do quick performance comparisons of different motors as well with an embedded comparator tool. Okay. So we can organize And here, from here, we can either export models or, you can bring in new projects which your colleague could share to you on so on. So we can organize, compare, and manage our e-motor projects efficiently. So make smarter decisions with the built-in comparison tools. So as I mentioned here, you're not starting from scratch, right? Instead, what you're doing is you are using pre-existing templates. You will be once you open the FluxMotor GUI, what you will see is a window called as the FluxMotor Supervisor, wherein we can choose wherein we can see the different types of machines that are available, and we can easily just choose what we want. So we have synchronous machines with permanent magnets, inner rotor and outer rotor. We have induction machines, okay, with the squirrel cage, inner rotor and outer rotor. We have wound field machines. We have DC machines, and we have more. I will show it to you in the software, and many more machine types are to come soon. So currently it is primarily radial flux, but axial flux machines are coming soon, very soon. Okay. And yeah, so comprehensive radial flux machine design capabilities for today's innovations and tomorrow's breakthroughs. Okay. So as I mentioned, right, we can test and evaluate the motors by using our automated report capabilities. So we can have a view of the electromagnetic performance. Results are automatically illustrated once the test completes running. So we have back EMF and cognitive tests. We have characterization maps, datasheet tests. More on this as I open the software. And we have, for machine performance, either for the working point or a duty cycle and or the complete efficiency map. So comprehensive testing and evaluation tools to analyze, validate, and optimize our electric motor performance. So what you see here is basically the magnetic flux density of the output. And similarly, we can do thermal design, and the test in flux motor as well. We'll design the housing, the fins, the cooling circuit, okay, whatever we need, and the external cooling, internal cooling, and how we can run these testers apart from our regular inputs. We can perform the electromagnetic tests, and from the losses that we get there, we can use those as a input to these thermal tests and perform either steady state or transient thermal tests, and get a complete view of how the motor is gonna look, what the temperature at different components of the motor is gonna look like. Okay, so yeah, thermal design and testing to predict temperatures accurately and optimize cooling strategies for reliable performance. So all of this can easily be done by even a person with no thermal or cooling background, because the software is basically just asking you for inputs. It's almost like AI in a way, wherein you just tell the software what you want it to do, and it does most of it. So we just need to see and uh, verify the whether we are content with the output of the design, or we want to run more iterations and so on. And yeah, NVH evaluation also we can do it, okay, in the early electromagnetic and design phase as well. So right from a single working point where we can do modal analysis, radiation efficiency, okay, and a lot more, outputs, maximum pressure on the NVH side, and we can do it for a complete spectrogram as well. So we can predict, analyze, and optimize NVH performance early in the design cycle for quite more reliable electric motors. And yes, this is what I was mentioning about the connection with different software. So we can connect with different optimization software, okay, like to run your DOEs, basically, wherein you keep set parameters, constant, and you want to vary another set of parameters, and you want the software to run multiple, simulation iterations, not just once at a time. So we can use that. We can do that using the DOE capabilities of our software like HyperStudy or Simcenter Heeds, or else we can, for system level simulation, we can export it to either Simcenter AMSM, and for advanced thermal NVH or electromagnetics, we can export it to SimLab as well. Okay, so pretty powerful coupling. And yes, for your power electronics and your controller designs, you can export it to PSIM. And yeah, I already mentioned about the quick report generation capabilities. So that is possible as well. Okay, so now I'll just quickly go to the software. Yeah. So what you see here is the window that you will see when you open FluxMotor for the first time. Okay, it has a pretty modern GUI, and currently, I'm using it in dark mode. You can change it to light mode as well. It looks pretty good. So these are the this is different motor templates that are available. So as soon as you open, you can see, right, synchronous machine. So here you can see a little bit more about each template, and we can see here, apart from the synchronous machine, permanent magnet, outer rotor, three phase, we have n phase machines and three phase machines as well for both inner rotor and outer rotor permanent magnet synchronous machines. And we have reluctance synchronous machines. Okay, we have wound field machines, and then we have different induction machines that we can design as well: inner rotor, outer rotor, okay, three phase and n phase. And finally we have a DC machine as well that we can design. Okay, so we want to just start a new design of any template. Just double click on this. For instance, I am choosing the three phase synchronous machine with permanent magnets in a rotor. It will open a page called as the motor factory. Okay. And yeah, till it opens, I do have an existing motor opened as well. We'll go through that. I just wanted to show you how you can open a new motor template here. Okay, and before we do that, let me just go back to the motor supervisor and your recently used motors. You can see it on the recent tab. Okay, you want to go to the motor catalog, and this is yeah. And another thing that I didn't mention earlier is you have existing catalog of a wide range of industry grade machines. Basically, they're all from the industry, right? And but a certain customers have directly allowed us to mention the names, and some have not. So for that, we've just mentioned standard names, but they are all industry grade machines across the different types that are available here. So you can easily use these as a reference starting point. Okay, and now let me just go back to the supervisor, sorry, to the motor factory. And this is a machine, again, another industry grade machine, which is already designed. And this is how the GUI is going to look when you open the software. Okay, so herein you can see how easily I'm able to just rotate and visualize it totally in its 3D view. You can just come here, hover your mouse over it. It will show it exactly what each option does. Here you have the 3D view. If you want to see it, from a 2D perspective, if you want to fit it to the screen, okay, you can just click this, and there are many more options. If you just want to reset it to the original view, if you want to explore the windings, and if you want to see an exploded view of the machine, you can do that as well. Okay, and similarly, you want to view, or you want to start hiding the components one by one. Okay, or you want to view only a certain component. All of those things can be done by using these options at the right. So it is very convenient to view the different components of the motor. And another very helpful feature, I would say, is this help option, okay, which will basically just take you to a help page wherein every single thing, right, every single feature, every single capability of the software is explained in detail. So it's almost everything's almost self-explanatory. We needn't worry about not being able to figure out stuff. Everything is here, right? So you can just go and you can just explore it once you use the software. And then yeah, so like this one by one, what you can do is you can define the different components of the machine, be it your motor specification. So here, this is the initial topology. What you can do is we can define the structural data of the machine, the dimensions, number of poles, slots, and more. Okay. And as far as the housing is concerned, we can define the motor casing, same as the shaft. These are necessary to perform thermal and electromagnetic operations. The magnet as well by let me just show it to you. Yeah. So herein you have different input methods, and herein you can just change the numbers. You can see if you just click on it, it will just highlight which component of the motor it is showing. Okay. And then similarly for shaft, so we can define the rotor shaft and bearings, and then similarly for the magnets. Okay, wherein we can here is where we can enter select the shape of the magnet. So this is the library. You can view here the different types of components that are available. Okay, and you have different viewing options for the same as well. So depending on your convenience, you can just explore, just pick and choose, and let the software do the rest. And once it is done, all we need to do is just parameterize, right? And then yeah, we can also view the polarization of the magnets. We can set it here as well, and we can also set skew if your motor has one in this same place. Okay, and then what we can see is we can see the slot definition, the stator part, right? So again, this is quite important as it directly influences the amount of current flowing in the winding, and which in turn produces the magnetomotive force and the magnetic induction in the air gap. Okay, so it also has an impact on the manufacturing costs of the stator. So we need to define these very carefully. So similarly, what we can do is we can pick and choose the slot shape from here. Different components are available, or you can just bring in your own as well. And you can add the lamination details, okay, and then the different shapes, and then the skew if you have any for your design. Okay, and then similarly we can easily define the winding as well. So this is, and as you are designing, right, this the right section is basically the inputs, the different inputs. What are you going to do? Towards the left, you have the different views of either your actual motor or your motor data in a document form. What you can visualize here from this data sheet option. Okay, so herein you can just come here and you can just visualize a lot of parameters that are there, all your inputs and the rest that the software calculates. So there it is huge. So a lot of analysis can be done pretty easily. And as far as defining the winding is concerned, you can just choose the type, and these are the different winding modes available. Auto mode is the easiest mode, where we are just basically telling the software the most basic description, the overall, the high level description of the feature of the winding, what you want to design, and you let the software take care of the rest for you. You go to easy mode, it will ask you to enter a few more parameters, and advanced mode a little more, and the software will do the rest. And in expert mode, you're basically designing the winding completely on your own at that point. So depending on your expertise, you can do it. And the coils as well can be defined here by means of numbers. Okay, and the inputs can be varied. It's not like you need to enter the same input. So wherever you see these arrow marks, you have different input options available. You can choose and enter those as well. Okay, and then in the as far as the insulation is concerned, we can add that here as well. End winding, and there is a lot more that we can define. And similarly, we can define the cooling as well. depending on your application by using the same methodology. Convection mode, and, different things can be taken care here. Similarly for the internal cooling as well. And then once we come to the material definition, so herein you can access your database, our database of materials. It has a wide range of materials. If not, we can always bring in our own materials. So you can see that when you click on a component, it's getting highlighted here, and you have a different list of materials from which you can choose your choose the material for your application pretty easily here. Okay, and then this you can define the materials here, and once that is done, your design is basically just done, right? It's completed. And then we can move to the test section. So in the test section, we have the different tests. Okay, we have the different electromagnetic tests. We have the thermal and the NVH tests as well. I'll just go through these as well. I'll tell you about it. So herein you can see that which tests have been performed here, right? It just shows you if there's a tick mark, it means that the test has been completed. If not, you haven't really performed it, right? So we can utilize the open circuit test to perform either the cogging or the back EMF tests. And herein you can just toggle these different options that you see. You will see that it takes you to that particular page. So we will evaluate the machine design. Okay, and when it's running in the open circuit test. So basically the speed of the motor is all that we need to do. So you can see here the inputs and the different outputs, what you can expect from running this particular test. So this is basically the no load voltage induced in the windings by the magnets. Okay, and then we can go to the next test from the characterization, which is the model test. Okay, so herein so this will basically evaluate the machine behavior and its drive and control systems. So if you have a uh, team who are working on the controller design, or if you want to work on the motor controller design for your motor, then what you can do is you can run these tests and it will give you all the parameters that you need to get started, basically. Okay, so it will enable us to model the electric motor during system analysis. Okay, and the calculated maps are displayed in this JDJQ area. So we have fluxes, inductances, torque, but iron losses, joule losses, and more. So we can run these tests as well. And we have different, along with the inputs here. Okay, we have inputs that will help us to either, if you want to save time and slightly reduce the accuracy, we can do that, or and vice versa, basically. And then the certain thermal parameters or certain electronics in the early power electronic stage or certain mechanical loss parameters. So all of these we can easily enter it here, and we just need to click on this play button, right? Utility play button type thing here, and it will do it. So you can see at the bottom right corner of the screen, it is running, and you can see it gives us how much time is remaining as well to run this particular test. Okay, and then similarly we can go to the and once you have the different outputs, of course, this you can easily just scroll down and visualize it. So here you have all the different maps that you see here. You can view the same as well. Okay, and then in the we can go to the data sheet test. Okay, so we'll be able to characterize the machine behavior at the base speed point. So we'll get the electromagnetic behavior of the motor considering our topology, the supply voltage, and the electrical current. Okay, including the command mode MTP, V, or MTPA as per our applications. So you can see here the different inputs and the many different outputs, what you can expect when you run the test, right? And then just to quickly go to the thermal test, this has already been performed. So we can evaluate the impact of the EMAG what we've run on the thermal behavior with different speeds and losses. We'll get an output which basically shows the temperature of our machine. So steady state, transient, there's a lot that we can explore and we can do here. Okay. And then we can go to the working point test either with a sine wave drive or a square wave drive. So we are looking into the computation, right? Okay, of a working point defined by a target current, control angle, and speed. So overview of the resulting electromagnetic behavior of the motor basically. So it gives us a very wide range of outputs as you can see here. The different iron losses, magnet losses, flux density values, and so much more. Okay. And a lot of interesting results which will be helpful for say different teams working on your complete motor design or your or whatever research work you are working from. So each results will have their own certain unique usefulness which you can go through, analyze, and make the best use of basically. So this is similar for the square wave tests as well. And then we'll just go to the performance mapping test. Okay. So wherein we can basically, see the overview of the electromagnetic and thermal behavior of the motor according to its speed. So we'll basically get the efficiency maps here. So they give us an estimate of the machine behavior at different speed or torque operating points. The map envelope represents, the domain in which the machine basically operates. So we can, yeah, we can define the main characteristics of the test as you see in the inputs, and you will get the different outputs as you see here. So there are a lot of what you see variations that we can do here as well based on working point, duty cycles, or and so on. And then finally, when we'll just look into the NVH test, okay, NVH prediction in the early electromagnetic design phase, looking into the sound pressure level, analysis of the electromagnetic forces in the air gap obtained from the magnetic flux density components, and more. So a wide range of outputs, including radiation efficiency, Maxwell pressure, and more are available. Okay, so it will give us a picture of the acoustic behavior of the machine. And then when it comes to the export, as I mentioned, right? So we have an automatic report generation capability. So once you select whatever you want from here, be it the design, test, or material, or whatever parameters you want, you just click on this apply inputs, this tick button that you see here, and you can just preview your report here. Okay, so it'll quickly give you the preview of the motor that of the report what you'll get. And once you click on this, it'll basically just it'll just create the PDF and it'll open it for you, so you can just view it. Okay, and then yeah, similarly we have exports to different software as I was mentioning earlier. The electromagnetics for your further electromagnetic analysis, you can always take it to Flux, or that is similar now, or your optimization or system levels analysis, we can export the component, export the motor to the particular software as well. Okay, now I'll just go back to our slides. Okay. Yeah, so just to give you a testimonial from a R&D electrical engineers from Bentel Motion Systems. So as you can see what he says here, right? FluxMotor gives our development and marketing teams a great tool for quick and very accurate decision making regarding new development requests. Designing an electrical machine in less than 1 day sounds incredible, doesn't it? And yeah, so this is the company from organization from where he works. So they design. So they've been designing and manufacturing advanced power and motion systems since 1983. So they work on high performance motors, alternators, and electrical brakes engineered to perform in the most demanding environments. with in-house R&D and a strong focus on innovation and quality. They serve a wide range of mission critical industries worldwide. So they serve the different industries they serve include defense, aerospace, semiconductors, and more. So yeah, just to give you, just to summarize, I think this slide summarizes it best. It is very easy to use and quite powerful, strong software, which will save a lot of time and time, effort, and cost that goes into designing these e-motors, and it will enable us to get our best possible designs ready at the shortest possible time. Okay. Yeah, so that is it from me as far as the content of today's webinar is concerned.